Okay, so today we're going to look at some examples with rational exponents. Now, we've already reviewed our basic exponent rules. So the first rule that I'm going to mention here that I want to make sure that you get is the one with the negative. So let's say we have 2 over x to the negative 2 power. Okay, so most of you remember that a negative exponent gets a reciprocal, except that we'd like to avoid a complex fraction, which is a fraction in a fraction. And so in order to divide by a fraction, we multiply by its reciprocal. All right? So what we would like to do is skip this middle step and simply just write the reciprocal of the fraction. So I see 2 over x. And so I'm going to write x over 2. And in doing that, I change the power from a negative 2 to a positive 2. And then you can apply the exponent to both quantities inside. X squared over 4. Okay, so for our second example, we're going to combine some exponent rules with our expressions. So let's say 3x to the 1/4 y to the 2/3 z all over 2x to the 1/5 y to the 1/6 all quantity squared. Okay, so you have two choices. You can simplify inside the parentheses, or you can do the square first. Okay, so we're going to do it both ways so you can see the difference. Okay, let's go with the inside first. Notice that we have 2x bases, 2y bases, and so I'm going to combine those first. X 1/4 x to the 1/5 gives us x to the 1/4 minus 1/5. So we do some common denominators, which gives us times 5, so 5 over 20. Times 4, so 4 over 20, which gives us x to the 120. Okay, so I'm going to leave my, all right, so we get 3 over 2, we get x to the 120. Okay, so I didn't leave quite enough room, so let's see, I've got some extra paper here. Let's see if we can do the y's. Okay, so we're going to get y 2/3 minus 1/6. Okay, so that's going to give us times 2, so that's 4/6 minus 1/6, so that's 3/6. 3/6 is really 1/2. Now the z is not going to move. Okay, so now we distribute this exponent to every term on the inside. So 3 squared is 9. Don't forget the coefficients. Okay, 120 times 2. 120 times 2. So this exponent is going to each of these terms here. Okay, so that's 1/10 x to the 1/10. 1/2 times 2 is y to the 1st. Now this is a 1 exponent, so z squared all over 4. Okay, so let's say we took an alternative approach and we wanted to do this outside exponent first. Okay, so we're going to distribute this exponent. Now the reason we can distribute is because there's no pluses or minuses here. Okay, so here we go. Let's do an alternative. 3 squared is 9. Okay, 2 times 1/4 is x to the 1/2. 2/3 times 2 is y to the 4/3. Z, 1 times 2 is 2, all over 4. Okay, so this is x to the 2/5, and this is, okay, 2/6 is 1/3. Okay, remember that when you multiply fractions, they go straight across. Okay, 2/3 times 2, so that's like 2 over 1, goes to 4/3. Okay, now I do the same rules here. So I keep my 9 and my 4 because those don't reduce. Okay, I've got the x's to combine and the y's to combine. So x 1/2 minus 2/5. So my common denominator is 10 times 5. So 5 over 10 minus times 2, 4 over 10. So that's x to the 1/10. Okay, so then I do my y's. Minus 1/3. Now they already have common denominators, so that's going to give me y to the, oh, I think I missed something. No, I didn't. Okay, so that gives me 3 over 3, which is 1. Okay, my z doesn't move, and my 4 stays. So it actually doesn't matter whether you start on the inside or the outside, you will end up in the same place. Okay, for the second set of examples, we're going to look at rationalizing, which means no fraction exponents in the denominator. Okay, so we're going to start slow here. So if I have 1 over y to the 1/2, I need to rationalize, which means I need to pick a quantity that I can multiply by. Okay, now that quantity needs to be equal to 1. Okay, and so when I do this, I need this exponent and this exponent to equal 1. Okay, so 1/2 plus what equals 1? 1/2. Okay, and so in order for this to be equivalent, we have to do the same thing on the top and the bottom. Okay, so now we're going to multiply. So I get y to the 1/2 in the numerator, and I get, okay, y to the 1/2 plus 1/2, y to the first. This is rationalized. No fraction exponents in the denominator. Okay, so let's look at a second example. What if I do something like 1 over x to the 1/3? Okay, so I still have to pick a quantity. Okay, now it's going to have to be the same thing on the top and the bottom, so that when I multiply these two things together, I will result in a 1 exponent. Okay? I need this to be 1. So what I'm thinking is, okay, what goes here? Okay, so 1/3 plus what equals, well, let's just do this. Let's keep it in the same denominator. Right? Let's give them common denominators. What is going to go in that numerator spot? A 2. 1 plus 2 equals 3. 2/3. Now multiply. Okay, so we end up with 1 times this, so this is x to the 2/3. Okay, x to the 1/3 plus 2/3 is 3/3 is 1. Okay, this is called rationalizing. Be careful not to do the subtraction of exponents. It will actually get you right back where you started. This is simplified because the 2/3 is less than the 1. Okay, let's do a slightly more complicated example. Okay, x to the 3/4, y to the -3, z to the 1/2, and y, all to the -1/4 power. Okay, so we can start on the inside or the outside. I notice that in the inside, I have these two y's that we could combine pretty quickly. So let's go ahead and do that. This negative exponent is in the wrong place, so let's move that. Okay, so this goes down to the bottom, and this is going to give us y to the fourth. Now, this negative exponent on the outside is a little bit tricky, so I'm going to go ahead and I'm going to make it a positive exponent. And in order to do that, I'm going to reciprocal this fraction on the inside. Okay, so there's no more simplifying that I can do on the inside, so I'm going to go ahead and distribute this 1/4 exponent. Okay, so 1/2 times 1/4 is 1/8. Fractions go straight across. 4 times 1/4 is 1. 3/4 times 1/4 is 3/16. Okay, so we're almost done. We've combined all of the same bases. We've distributed this outside exponent. The only thing left is to look at this denominator and decide how to get this fraction exponent out of the denominator. The only way to do that, to keep your expression equivalent, is to multiply by 1. Okay, so I'm going to do an x. I need to pick my exponent. And so what I'm thinking is that 3/16 plus what? Now I'm going to keep common denominators, is equal to 16/16. Okay, so you are picking the numerator. 3 plus what equals 16? 13. Okay, so we're going to add the exponent, 13/16. Okay, now simplify. Z to the 1/8, y to the first, x to the 13/16. All over. Okay, what's my denominator? Well, we already know it's x to the 3/16 plus 13/16, so that is x to the first. Notice that the x, the 13/16, is less than the 1. Okay, let's go ahead and do another example. Let's do quantity 2x y to the negative 1/4 over x to the 1/6 and z to the 2/5. Quantity cubed. Okay, now I can start on the inside, or I can start by distributing the 3 power. I do notice that I have 2 of the same bases, so let's go ahead and do that first. 1 minus 1/6. Okay, so we're going to do common denominators. 6/6. So we get x to the 5/6. Okay. And then let's go ahead and move this negative exponent to the denominator. Okay, and now let's cube. Okay, so 2, right, this is the first power, so it's times 3, so it's 2 cubed. 2 times 2 is 4, times 2 is 8. Okay, so 5/6 times 3, the 3 and the 6 actually reduce, so it's just 5/2. Okay. Okay, so y to the 3/4, okay, and z to the 6/5. Okay, so I've done all the exponent rules that I can. I've combined the same bases. I've distributed my outside exponent. The only thing I have left is I have 2 fraction exponents in the denominator. Now, we have 2, and so this quantity still has to be equal to 1. So I'm going to need y, and I'm going to need z. Okay, so let's figure out the y exponent first. Okay, so we have 3/4 Okay, so I've got to pick that exponent, 1. Okay, so we're going to get a 1/4. Okay, now we have to do the z. A little bit trickier here. So we have 6/5 plus something over 5. Now, 6 is already more than 5, and so we're not going to equal 1 like we did in the y example. We're going to go up to the next integer, which is 2. I want to avoid the fraction exponent, so we have to be equal to an integer. Okay, so 4. 4/5 is going to be our number. Most of the time a 1 will work, but if not, pick the next integer available. 6/5 is more than 1, so we're going to go for 2. Okay, let's multiply. Okay, so the 8 stays. Notice that x is not the same base here. Okay. All right, so y 3/4 plus 1/4, 4/4, y to the first. Okay, z 6/5 plus 4/5 is 10/5, which is z squared. Notice that the exponent of the numerator here is less than the exponent of the denominator. That is simplest form, because if you were to subtract 4/5 minus 2, you would end up with a negative, which would put the variable in the denominator, which is what we're trying to avoid.